Okay, last couple things we need to be able to do are write equations from our roots, and if I'm given a point and I want to go through that, I want to be able to include that in my equation too. And the other one is just a real basic sketch of the graph from roots and leading coefficient and power of the polynomial or degree of the polynomial. So I'm just going to kind of make this one up as I go. If I want to write an equation from roots, let's say we've got a list of roots that I know for my polynomial. A couple easy ones, 2, -3, and let's say, well, we'll keep them whole for this first one. So 2, -3, 4, and 1. Okay, so if these are my roots and I want to write an equation of a polynomial that goes through these, that means I'm going to have factors of x minus 2, x plus 3, x minus 4, and x minus 1. Okay, and then let's say I want it to go through a specific point. We'll give it a point -1, 5. Okay, I want to go through that point. Well, what I'm looking for is my a again. Okay, so I need to find my a, which means I'm going to plug these in for my x and y. So right now I've got this. So I would have 5 equals a times, put -1 in here, I get -3. Put -1 in here, I get 2. -1 in here, I get -5. -1 in here, I get -2. Multiply all these out. Let's bring my calculator up again. -3 times 2 times -5 times -2. Okay, so I've got 5 equals -60a. Divide by -60. I'm going to get -112 equals a. So then y equals -112 x minus 2, x plus 3, x minus 4, and x minus 1. Now this isn't the normal way that we see polynomials, so we're gonna multiply this out too. I'm gonna leave this to the very end because that'll, I don't want to introduce fractions any earlier than I need to. I'm gonna multiply these two guys together first. X squared plus 3x minus 2x is plus x minus 6. Okay, next I need to multiply this guy in. I'm just going to do one at a time. If you wanted to, you can multiply these two together and then multiply them together, but I like to just multiply by binomials instead of trinomial and trinomial. So I put the x in, I'm going to get x cubed plus x squared minus 6x. When I put the -4 in, I'm going to get minus 4x squared minus 4x plus 24. Simplify by combining like terms. So x squared minus 4x squared is minus 3x squared. We got a total of -10x's plus 24. And then the last one is x minus 1. So I multiply this in, I get x to the 4th minus 3x cubed minus 10x squared plus 24x. Once I put the -1 in, I'm going to get minus x cubed plus 3x squared plus 10x and minus 24. So when I add these up, I get x to the 4th minus 4x cubed minus 7x squared plus 34x minus 24. And the last thing is to distribute my -112. So 1/12 times this is going to leave me with -3. This is going to be, oh wait, it was negative. That should be positive. Negative. This will be positive 7/12 x squared. This will be negative 34. The 2 from this, so cancel the 2 from that and make it 17/6. And here this will turn into just positive 2. And that would be my equation of the polynomial that has those roots and goes through the given point that I had. And a way to check this, of course, would be on the calculator. Plug in your final answer. So -1/12 x to the 4th plus 3 x to the 3rd plus 7/12 x squared minus 17/6 x plus 2. If we graph this, okay, we kind of get that. Let's zoom to fit here. I'm not seeing all my zeros on there. I should see zeros all over in here, so I must have done something wrong. If I plugged in -1, got out -5. Okay, I found my mistake here. When I took this times 1/12, it's not 3, it's 1/3. 1/3, this is 7/12. This is 17/6, that's 2. So let's change that. So I don't want 3, I want 1/3. So I'm going to insert parentheses 1 divided by, insert my other parenthesis there. Now we should be good to go. There we go. I'm crossing at -3 like I should. Crossing at 1 and 2 and 4. And to make sure that I go through this point, I'm going to calculate the value when x is -1, and it's 5. Okay, so that's how you can check your answer. So that's how you write equations, given roots. If you're given, let's say you're given a complex root. Okay, so you're given a complex root of 1 plus 2i, and let's say they give you another root of -1 and 2. Well, if this is a root, you have to remember that if that's a root, this is also a root. So you'd have those, and then you'd multiply them together. So I have a factor of 1 minus this root. Okay, I have a factor of x minus this root. And x plus 1 and x minus 2. We'll multiply these together first. So I could start by, okay, x times x is x squared. X times this is negative x times 1 minus 2i. And then this is negative x times 1 plus 2i. And then multiply these together. And since they're conjugate pairs, I'm going to just be squaring them both and subtracting them. So 1 squared minus 4i squared. I squared is -1. So here, I'll do it up here. And 1, I'd have minus 2i plus 2i cancels out. This is 4i squared, so minus 4i squared. I squared is -1, so this really turns into 1 plus 4, which is 5. So I should have plus 5 out here. If I distribute my negative x's here, I have negative x plus 2ix, negative x minus 2ix plus 5. Negative 2ix and plus 2ix cancel. So I've got minus 2x plus 5. Okay, and then I would just keep multiplying. Okay, next I'd multiply this in. And then I'd multiply that one in. So I'll just keep doing that. X cubed minus 2x squared plus 5x plus x squared minus 2x plus 5. Combine like terms. So that's minus x squared. This would be plus 3x plus 5. Multiply this whole thing by our last root. X to the 4 minus x cubed plus 3x squared plus 5x minus 2x cubed plus 2x squared minus 6x plus 10. So x to the 4th. I have a total of 3x cubed. I have a total of 5x squareds, negative x, and plus 10. And if they give you a point, of course, you do the, you do your a thing, probably up at this step here with both roots on here. But to check to make sure we've got everything, we can graph this one. So x to the 4th minus 3x to the 3rd plus 5x squared minus x plus 10. Okay, and what were my zeros here? Should be seeing -1 and 2. I'm not seeing any. So let's check my math here. X minus 2x, x squared minus 2x squared plus 5x, plus x squared minus 2x plus 5. So this would be negative x squared. It's 3x and 5. Minus 2x cubed plus 2x minus 6x plus 10. Okay, I see it. It should be -10. It's -2 times 5 is -10. There we go. Crossing at -1 and 2, just like I should be. Okay, so that's writing equations from roots. Graphing. So let's say I was given, the roots and the leading coefficient. So let's say, I'm just going to make this one up, so it probably won't actually work. But if I just want a rough graph of something like -3x to the 4th plus 7x cubed minus 18x squared plus 12, and I was told that it has roots of, let's see, I need 4 of them. -1, 3, and 2/3, and let's just do +1 also. Okay, so these probably aren't real roots of this. They are possible roots. Okay, I was making sure I was looking at my P's and Q's, so I could have 2/3. And they just want a rough sketch of the graph. Okay, all you're going to do is you're going to plot your roots, and then you're going to look at your end behavior to make sure it follows the right end behavior. So my roots, -1, 1, 3, 2/3 would be in here somewhere. And my end behavior says that both sides should be pointing down, because even power, both are doing the same thing. Okay, it's negative, so they're both pointing down. And you're just going to connect your roots to your end behavior with a smooth, flowing graph. Okay, so I know this side's going down. It's got to come up and hit this. At 2/3, it's got to come back up right there. And then it's got to come and go back through that last root. So I kind of missed the root, but I mean, that's basically one representation of what the graph would do. And everyone's graphs will look a little bit different, but it's not going to be a huge part of what we're doing since we've been focusing on using our calculators to do the graphing, and there's no reason not to. So this pretty much wraps up the chapter. Finding roots, finding possible roots, dividing them out, writing equations from our roots, and making just generalized graphs using roots and end behavior. That's important just so you have a general idea of what your graph should look like, in case you don't have your graphing calculator or something like that.